Hey there, so in this video we are going to learn about multi-dimensional arrays in C++. Now in the introductory video we have already seen that in multi-dimensional array we can have multiple types of arrays. So for example, in multi-dimensional category we can have arrays like 2D array, 3D array, 4-dimensional array, 5-dimensional array. But I have already told you this, that we usually don't use arrays like 4D array, 5D array that often, okay? And I'll say even we don't use 3D arrays that often. So that's why we are going to restrict our course till two-dimensional arrays. Okay, so in multi-dimensional category we are only going to see the two-dimensional arrays, and we have seen that two-dimensional arrays looks something like this. You can see it on my screen. They look like a table. Okay, it's like a table structure. We have multiple rows and multiple columns. So whenever arrays contains multiple rows and multiple columns, they can be called as two-dimensional array. Or I'll say whenever the arrays looks like a table, then they can be called as multi-dimensional array. Now let's see in this video how we can create the multi-dimensional arrays in C++, how we can initialize them, how we can use them. Okay, so that's what we are going to see in this video. See, this is one example of multi-dimensional array. This is 4 by 7 multi-dimensional array or two-dimensional array. Why it is 4 by 7? Because you can see we have 4 rows. Now these are the indexes which starts from 0. So this is 0th row, this is first row, second row and third row. Okay, similarly we have 7 columns which again the index starts from 0. So 0th column, first column, so on, and this is the 6th column. So that's why it is called as 4 by 7 2D array. Okay, now this one, the second one, you can see it is 2 by 2 two-dimensional array, because in this array we have 2 rows and 2 columns. Okay, so based on how many number of rows you have and how many number of columns you have, you can basically tell the dimension of your two-dimensional array. Okay, so whenever you tell the dimension, you first tell the count of the row and then you talk about the count of the column. So in this case, this first 2 is count of the row and the second 2 is count of the column. In this case, first 4 is count of the row and second 7 is count of the column. So it's going to be always same. First we give count of row and then we give count of column. Okay, now let's go to our Visual Studio Code and let's see how we can create two-dimensional array. Let's see the syntax to create two-dimensional array. It is super simple. Okay, see, let's say I want to store integers. Okay, see, again in two-dimensional array we can store only homogeneous elements. We can't store heterogeneous data in the two-dimensional array as well. That's why you have to specify the data type of the element that you want to store in your array. So let's say I want to store integers, so I'll write data type as an integer. Okay, then you'll need to specify name of the array. Let's say I'll give name as, let's say, ARR2D. Let's say this is the name of my array, ARR2D. Okay, now you need to give square brackets 2 times. I'll say, see, you will need to give 2 open and close square brackets. Now the first open and close square bracket is going to contain number of rows, and the second open and close square bracket is going to contain number of columns that your array is going to have. All right, now let's say we have to construct the first array that I showed you on whiteboard, which contains 4 rows and 7 columns. Then what you will need to do is, in the first open and close square bracket you will need to write count as 4, row count as 4, and in second open and close square bracket you need to write column count as 7. Okay, so basically we are constructing an integer array of size 4 by 7, 4 rows and 7 columns. Let's say you want to construct a character array. Let me name it as let's say ARR1 or 2D or something. I know it is a bad name. Let me give it name as ARR2D char, and this one will be ARR2D int. Okay, and then let's say you want to create it as 2 by 2 array, then the row count will be 2 and column count will be 2. Okay, so basically if we write the general syntax, you need to write data type first, then you need to write name of the array. Okay, name of array, then you need to write row count in first open and close square bracket, and then you need to write column count. All right, that's it, and then you need to end the statement with the semicolon. So in this way your array will be created. Now let's verify whether this array is getting actually created, some space is actually getting allocated to this array or not. So for that what we can do is we can just print the size of the array. So I'll print size of the first array. So I'll write size of arr2d int. Let's see what is the size of this array. So we'll use the size of operator, and then let's pass this array name to size of operator, and then I'll write endl. Similarly, let's print size of character array. Let's see what we get as the output. Now I'll quickly compile this code. Let's write g++ 06 multidimensional array.cpp. This is my file name, and let's execute this code. Okay, you can see size of 2D integer array is 112 bytes. Okay, let me copy this and let me paste it over here. We'll see how this output is coming. So it is 112 bytes. And size of the character array is coming as 4 bytes. Okay, now let's understand how this thing is working. See, we have this character array. Let's first talk about the character array. So in the character array we have 2 rows and 2 columns. Okay, so that basically means we can store 4 different elements. Okay, let me quickly show it to you on the whiteboard. You see, in this 2 by 2 array you can clearly see that we can store 4 different elements, 1 2 3 4. Okay, and if I want to store 4 different elements of character type, you know, each and every character is going to take 1 byte of memory, so it's going to be 4 into 1 byte, that is 4 bytes. That's why this value is coming to be 4 bytes. Now let's understand how things are working in case of integer array. See, we have 4 rows and 7 columns, so in each row we have 7 elements. So in that way we have 4 rows, so 7 into 4 is 28, correct? So we have 28 different elements, and basically if you multiply 28 by 4, it is going to be 112 bytes. Okay, so we have 28 elements and each element is taking 4 byte of memory, so 28 into 4 is 112, and that's the size of your integer array. So basically we have verified that our arrays are getting memory in our RAM properly, and the syntax is also correct. Okay, now let's take a next step. Let's see how we can initialize these arrays. Okay, how can these arrays can be initialized? So in order to initialize these arrays, we can use initialize the list. Okay, so what is the syntax? Just focus on the syntax. You need to write is equal to assignment operator, then curly bracket open and close. This is your initialize the list. Now in 2-dimensional array we have multiple rows. Okay, and in each and every row we have multiple elements. So basically what you can do is, in these curly brackets you will write multiple curly bracket, and each and every internal curly bracket that you are writing inside this outer curly bracket represents one row. Okay, it's very simple, very straightforward. See, in this case we have 4 rows, so I'm writing 4 curly brackets. Let me reduce this size little bit. Let me make it as 4 by 3. Okay, so if I make it as 4 by 3, then it will be having 12 different elements. Okay, and then each and every element is consuming 4 byte of size, so 12 into 4 is, I guess, 48. So size will change to 48 bytes. Let's quickly verify this. Yeah, you can see the size is coming as 48 byte. I hope you got the reason behind why this size is coming to be 48 now, because we have 4 rows and every row contains 3 elements, so we have total 12 elements in the array. Each element is taking 4 byte of size, so the array will take 40 byte of size, 48 bytes of size. Now how we can initialize the individual row? So it's very straightforward. The first row can be initialized with this initialize the list, this small internal initialize the list. Then this initialize the list is for second row, then third row and fourth row. So in this way you can write the list for each and every row. Okay, so let's say the first row is going to have 1 2 3. Let's say the second row is going to have 4 5 6, and third row is going to have, let's say, 7 8 and 9, and the fourth row is going to have 10 11 and 12. So in this way you can give the initializer list. Similarly, if you want to initialize this character array, you will do the same. We have 2 rows, so I'll write 2 curly brackets, open and close curly brackets inside the initializer list. And let's say I want to initialize first row as small a and small b, second row as small c and small d. So in this way you will do it. Okay, so in this way you can initialize your 2-dimensional arrays. Now this is the one way of doing it. You have one more way of initializing a 2-dimensional array, so I'll just comment this thing out and I'll show you the another way of initializing the 2-dimensional array. See, you can also remove these curly brackets. See, this is also feasible. You can also write the initializer list like you write it for one dimensional array. This is also possible, okay? This is also allowed in C++. Let me tell you how the compiler is going to perform the initializer. Before that, let me format the document. Okay, see, if you write initializer list like this, in this case you have an initializer list, and in that initializer list you have all the elements one after another. So how compiler performs the initialization? So compiler sees the column count, okay? In this case the column count is 3, okay? So what it is going to do is it is going to take first 3 elements. Because the column count is 3, it is going to place them in the first row. Then it is going to take next 3 elements, it is going to take or put them in second row. Then next 2 element, it is going to put them in the next row, which is the third row, and then it will pick last 3 elements and it is going to put them into the fourth row. So in this way the compiler will perform the initialization. So you don't need to write curly brackets around the element, or you don't need to group them. Compiler will do it for you. But there are some cases which I am going to explain you in a while. There are some places where it is better if you write initialization like this, okay? I'm going to explain what are those cases when you can, or when you should write initialization in this way. But for now you just understand, or you just keep this thing in your mind. You can also write initialization in this way or in this way. Both the ways are fine, okay? Now there is one small thing over here, one small important thing over here. See, in case of one dimensional array, we know that if we are giving initializer list, then the size is optional, okay? You can also skip writing the size of the array or length of the array. That is optional in case of one dimensional array. Now in case of two dimensional arrays, this row count is optional if you are writing the initializer list. This is very important. See, in case of two dimensional arrays, this row count is optional. You can skip the row count, but you still need to write the open and closing curly bracket, as we also do it in one dimensional array. The size is optional, but we still write open and close, opening and closing square bracket. Similarly, in case of two dimensional array, I am repeating it once again, the row count is optional. You can skip the row count when you are giving the initializer list, okay? So always remember, in case of two dimensional array, if you are giving the initializer list, you can skip the row count, but the column count is not optional. Column count needs to be given. Now why column count is not optional and row count is optional? I'll tell you the reason. See, what compiler does whenever you provide the initializer list, compiler is going to take the element, or it is going to group the element based on the column count, okay? Because we can have n number of rows, but in all the rows we are going to have same number of column or same number of elements, right, in two dimensional array. That's why the column number or column count is fixed. So based on the column count that you are giving, compiler is going to perform the grouping, and then it is going to create the rows for you, or it is going to calculate how many number of rows your array is going to need. So in this case we have 3 elements, or 3 as a column count. So basically that means in each row you are going to have 3 elements. So compiler is going to do the grouping into 3. So this is the first group, this is the first row, this is the second row, this is the third row, and this is the fourth row. In this way compiler is going to know how many rows your array is containing. So that's why row count is optional if you are giving the initializer list. I hope you are clear on this point. So now let's move to the next important thing, that how we can access the elements of an array. We have seen in case of one dimensional array, we have something called as subscripting operation, by which we can access individual element of an array. So in two dimensional arrays as well, we have subscripting operation, with the help of which we can access individual element of an array. Now let's see what is the syntax of accessing an individual element of two dimensional array. It is super simple. See, right now our array size that we have changed is only this one, this much, okay? So just focus on this part, because we have modified our array size to 4 by 3, okay? So what elements we have inserted into this array is 1 2 3, then here 4 5 6, then 7 8 9, and then 10 11 12. So this is how our array looks right now. Now let's say you want to access this element, okay, this element over here. See, name of our array is ARR, let's say, okay? So how you can access this element which is present at this location? So it's super simple. You just need to write name of the array, then in first square bracket, opening and closing square bracket, you need to write the index of the row in which the element is present. So in this case it is 0. And then in second opening and closing bracket, you need to write index of the column in which the element is present. So in this case it is 0. Okay, it's super simple. You need to write name of the array. So let me go back to the code and we'll see how we can access the element using the code. So this is my array name. I'll write name of the array. Let's say I want to access the first element, so its row count is 0 or row index is 0 and its column index is also 0. So I'll write it as arr2 int 0 0, and let's print endl after this. Let's see whether this works or not. Let me clear the terminal. See, we don't need these cout statements now, so I'll comment them out. So let's compile the code and let's execute it now. You can see it is printing 1. So it is printing the first element. Now let's print the first row. Let's print the entire row. So how we can print the entire row? See, the first row is basically indicated by this index, which is 0. Okay, and then in that row we have 3 columns. So first column has index as 0, second column has index as 1, and the third column has index as 2. So if you want to print all the elements of the row, what you just need to do is you just need to print different column indexes. So what I'm doing is I'm printing arr2d int of 0 0, then arr2d int of 0 1. So you can see row count is same. I'm only changing the column index or column count. Okay, now let's see whether we are getting the entire 0th row or not, or entire first row or not. You can see we are getting entire first row. So the first row is in this case 1 2 and 3. Okay, see what I'll do is instead of printing endl everywhere, I'll just print space, and then once the row ends I'll print endl. Okay, cool. Similarly, we'll print the second, third and fourth row as well. So in order to print the second row, what we just need to do is we need to change the row count. Okay, so for second row the row count will be 1. Similarly, for the third row the row count will be 2, and for fourth row the row count will be 3. Now let's see whether we get the entire array on our screen or not. So let's compile the code and let's execute this. You can see we are getting the entire two-dimensional array. You can see it is printing 1 to 3 as a first row, then 4 5 6 as a second row, then 7 8 9 as a third row, and then 10 11 and 12 as a fourth row. So in this way the array is getting initialized and array is getting printed on the screen. Okay, now let's change this boring stuff that we have written from line number 14 to line number 28. Let's change this because this is so manual. Okay, so what we'll do is we'll write a loop to do this task. Okay, so how we can write a loop to do this task? See, it is very straightforward. If you observe carefully, in order to print two-dimensional array, what we need to do is we need to access two indexes. First index is row index and second index is column index. So first we start with a row and then we print each and every element of that row. Okay, so basically what we can do is, see, we can write one for loop which will start from 0 and which will go till row count or the maximum row count. Okay, so in this case for this array the maximum row count is going to be 3. Okay, so I'll write I less than equal to 3 and then in every iteration we'll increment I by 1. Okay, see, the maximum row count is 3. Okay, so this is my for loop. So what this for loop is going to do is it is just going to generate row counts for me. Okay, now for every row you also need to generate column counts. Okay, so what we can do is inside this for loop you can write another for loop which will generate column counts for you. So I'll write int j. See, over here I am using I, so here I'll use another letter or another variable name. I'll name it as j. J will start from 0 and j will go till column count or the maximum column count. So what is the maximum column count? Maximum column count is 2 in this case, and in every iteration we'll increment j by 1. Okay, and now what we just need to do is we just need to print, see, this is very simple. Now we just need to print arr2 d int, instead of 0 0 I'll write I and j, and then once this for loop gets over I'll print end line. So I'll write cout endl. I'll explain you how this for loop is running. See, first of all, the outer for loop will start executing. initially I will be 0, so we'll come inside this for loop. Then inside this for loop we are writing another for loop. Okay, now this for loop will start executing. Right now my I is 0, my j will also become 0, so it will print arr2d int of 0 0. Okay, then we are still inside this for loop. This for loop is still under progress. Okay, so j will increment, j will become 1, my I is still 0. Okay, because until and unless the entire body of for loop doesn't get completed, will not go to next iteration, I will not increment, right? So we are still waiting for this for loop to get completed. So j will become 1, so array of 0 1 will be printed on the screen. Then again j will be incremented, j will become 2, then array of 0 2 will be printed on the screen. Again j will increment and j will become 3. Now 3 less than 2, this condition, 3 less than equal to 2, this condition is basically false. So this for loop will terminate and then we'll print endl. So that basically means we have printed the entire first row on the screen, and then this for loop has got terminated. Now this I will increment because the entire body of the for loop has got completed. So I will increment, I will become 1. Once I becomes 1, 1 less than equal to 3, this condition is true 3, so we'll come inside the for loop body. Now inside the for loop body, again the same thing will happen. J will start from 0, I is 1 in this case, so it will print the entire second row. Then again it will print the third row, then it will print the fourth row, and then the outer for loop will stop, and then in this way the entire array will be printed on the screen. So now we don't need this big code that we have written previously. Now let's compile and execute this code. Let's see whether this works properly. You can see it gives you the same output. Okay, so in this way you can use nested for loops to print the two-dimensional array. See, you can pause the video over here and you can try this code on your machine, and it's super simple. If you still have any doubts in your mind about this code, you can try to dry run this code by taking a pen and paper, and you will understand the code properly. It's super simple. Okay, now let's say if you want to print this array, the character array, how you can do it. See, over here in case of character array, the row count is 2. Okay, we have 2 rows. So over here the maximum index is going to be 1. Okay, because index starts from 0 and we have only 2 rows, so the index of the last row is going to be 1. Similarly, index of the last column is also going to be 1, so you will change the conditions over here and you will also change the name. Okay, now let's see. I'll clear the terminal, I'll compile and execute this code. You can see it is printing the character array. Okay, so in this way you can print the character, or you can print any array using the nested for loops for the two-dimensional arrays. Okay, now let me tell you one important thing over here. For that, what I'll do is I'll comment this out and I'll remove the comments from these lines. Okay, so I was saying whenever we give initialize the list, we don't need to give row count, so I'll just remove the row count from here as well. Okay, now why I was saying this syntax is sometimes helpful as compared to this syntax, the reason for this is, let's say you want to initialize the rows, but let's say you want to initialize the first row only with these 2 elements. See, the row is going to contain 3 elements because the column size is 3. Okay, but let's say you just need to pass the initializer for first 2 elements, okay, or first 2 columns, and you don't need to give any initializer for the third column of the row. So this is possible with this syntax. You can see in first opening and closing curly bracket, I have given only 2 elements, 1 and 2. Okay, I'm not giving the third element for the third column, and still that is feasible, that is fine. Similarly over here I'll just give 1 element. Let's say over here I'll not give any element, and over here I'll give 3 elements. Let's see what happens now. So let me change this back to the old example. So the row count or the maximum row index is 3 for this array, the maximum column index is 2, and array name is this one. So let's see what we get as the output. Okay, you can see whatever elements you are passing are getting stored in that particular row, and the remaining elements in that row for which you are not giving any initializer, those elements are getting initialized with 0. Okay, you can see it over here. You can see the first element, first row is containing 1 and 2, and the remaining element is 0. and then in second row we have 4 and the remaining two elements are 0 0. In third row we have all zeros, and in fourth row we have 10 11 and 12, which is getting passed from here. So in this way the two-dimensional array gets initialized whenever you use this syntax. Now let's see what happens if you use this syntax and if you pass less number of elements in the array. Let's see what happens. Let's say you have 4 rows. See, I'll give row count in this case. I'll explain you why I'm giving row count. Let's say you have 4 rows, okay, but you are passing less number of initializers in the initializer list. Let's see what happens. I'll compile this code once again and I'll execute it. You can see in this case what is happening. Compiler is doing the grouping based on the column count. In this case the column count is 3. So the first row is going to get first 3 elements. The next row is going to get next 3 elements, and the next row is going to get next 3 elements, but in this case we don't have 3 elements, we just have 1 element left. Okay, so you can observe over here, first row is taking 1 2 3, second row is taking 4 5 6, and third row is taking only 7. Okay, because we just have 1 element left for the third row, and the remaining things will be initialized to 0 0 0. Okay, you can see the third row, remaining elements of the third row are getting initialized to 0 0 0. Similarly, the remaining elements of, or all the elements of the fourth row are getting initialized to 0 0 0. So in this way the C++ initializes your two-dimensional array with this syntax. Okay, now what will happen if you don't give row count in this case? If you don't give row count in this case, what C++ is going to do, again C++ is going to do the grouping, but in this case C++ will be able to form only three rows. This is the first row, this is the second row, and this is the third row, which contains only one initializer. Remaining two columns don't having any initializer, so C++ will be able to form only 3 rows in this case. So basically this time the array will have only 3 rows. Now how we can confirm that this time array is having only 3 rows? So we can print size of the array, and let's see what is size in this case. So I'll clear the terminal, let's compile the code and let's execute it. You can see in this case the size is coming out as 36. Okay, why it is 36? Because we have 3 rows and we have 3 columns, so 3 into 3 is 9 elements, and 9 into 4 bytes is 36. Okay, so in this way, in this case the C++ is able to form only 3 rows. Okay, but let's say if you want to tell C++ explicitly that I want this array to have 5 rows, then you can do that by specifying row count over here. So if you specify the row count, this time C++ will create array of size 5 by 3, 5 rows and 3 columns, and the remaining elements which don't have the initializer will get initialized with 0. Okay, so basically what happens is whatever elements which don't have the initializers in the initializer list gets initialized to 0 if your array is of integer type. If your array is of character type, the remaining elements gets initialized with /0, which is a null character, and for floating and double type arrays, the remaining elements will get initialized with 0.0.